All right, welcome back to pre-calculus. We are going to be looking at graphing a polynomial now. So this is the problem we have is b of x is equal to 2x cubed plus 2x squared minus 8x minus 8. Boy, there's a lot of even numbers there. So the idea here is we are going to go ahead and detail the end behavior. We're going to look at the x-intercepts, the y-intercepts, and make a little sketch. First thing we're going to do is, okay, end behavior. What degree polynomial is this? This is degree 3. My leading coefficient is greater than 0. So that's like the first thing is to get an idea of like, let's get a kind of a taxidermy this thing and figure out, or taxonomy rather, figure out like who are we dealing with. So because I know it's degree 3 and that my leading coefficient is positive, I know that we're going to have end behavior such as this. We're going to say as x goes off to infinity, b of x also goes off to infinity. As x goes off to negative infinity, b of x goes off to negative infinity. Okay, it's kind of like as we get further this way, we go further and further down. We get further and further positive, b of x is going to get bigger and bigger and bigger. Okay, so that's the first little thing to deal with. Now we have our end behavior sitting here. Now we have to know where our x-intercepts are. Well, we got to factor this because really what we're trying to do is we're going to set that equal to 0. Okay, so sometimes this is a factored form, and this is a really easy thing to figure out, and sometimes it's not. In this case, it's not. So we're going to have to factor this. Usually, when you have cubics, you can factor them in first pair, second pair. I think that kind of matches with this one. If that doesn't work, you can also factor them like sometimes it's like a 1 and 3 beat and a 2 and 4 beat, kind of like music. Okay, that's how you should group them every once in a while. Okay, this doesn't happen very often, but there are places where this does happen, where you might have a grouping of 3 and a grouping of 1. Okay, it's the last choice you're going to make, but generally, first pair, second pair is the thing that does it. That's how I'm going to group them. So I'm looking at my first pair. What's common to the first two terms? Well, 2 certainly. And then it looks like there's an x squared. So if I pull a 2x squared out of this, what is left? And that looks like an x because one of the x's is left. And then I pulled out a 2x squared. The only thing left is just a 1. It's kind of like a placeholder. Next, we're going to go ahead and say, okay, let's pull out the second pair. So what is left over in the second pair? It looks like a minus 8. And if I pull that minus 8, we're going to end up with an x plus 1. Okay, now these are the same. We can factor by grouping. So what we're going to do is we're going to pull this x plus 1 forward, x plus 1, and what are we left with? We're left with 2x squared minus 8. Remember, the goal here was equal to 0. So I'm going to do a little bit further. I'm going to say this is 2. I'm pulling out a 2 to factor it completely. We have an x plus 1. If I pull that 2 out of here, we have an x squared minus 4. Again, factoring completely. We can keep going. So we have a 2, x plus 1, x minus 2, x plus 2 equals 0. Now, we have our 0 factor principle. So what we're going to say is x plus 1 is equal to 0, or x minus 2 is equal to 0, or x plus 2 is equal to 0. And we're going to solve each of these. So we have x is equal to negative 1, or x is equal to 2, or x is equal to negative 2. Those are my intercepts. Okay, so when I go to start drawing this thing, I've got some zeros to kind of pay attention to. Okay, so we can go ahead and start drawing a little bit of an axis here. So we have my x, I have my y. Okay, again, I'm just kind of making a little note for my end behavior. And then I'm going to look at this one and say, okay, we have negative 2. Okay, we have negative 1. Okay, and we have positive 2. And that's kind of what I'm looking to deal with here. So right now, I know those are my zeros. So we're looking at something like this. We're going to come down. We're going to look at what's the power on these? These are all power 1. They're all odd. They're all going to break through the axis. So it's going to break through. It's going to come down here. And then we're going to come down. And then we're going to come over here and something like that. Okay. In pre-calculus, we don't care where the turning points are, so wherever you draw them is the right answer. Okay, as long as we don't do something like that. We have like multiple turning points. We only have we're going to have a maximum of 3 minus 1, 2 turning points. So here's 1, here's 2. So don't draw like squiggles in here and make it look like that. This is a continuous polynomial. So we're not going to have like, you're not going to draw it so you have like this and then it skips up here. No, no, that would be wrong. It's one smooth, continuous curve. The only thing I have left to do is where is my y-intercept? Okay. And that is when x is equal to 0. So we're going to go plug this in. If I go back and look at my problem, that was going to be 2x cubed. Okay. So back to 2x cubed plus 2x, it's a minus, but 2x squared minus 8x minus 8, I believe. All right. So that was our, I think that was our first. Let's double check. Yeah, it is. I got my things right. Plug in x equals 0. Well, that's 0. That's 0. That's 0. We have minus 8. So we have 0 minus 8, negative 8. So I'm going to go down here and I'm going to say, oh, there's 0, negative 8 here. So we're going to touch that point, and then we are there. We have all the little pieces here. So we could go back and we could say, okay, my x-intercepts, okay, and we're going to say this is negative 2, 0, negative 1, 0, 2, 0. When you are reporting features on a graph, you give me both the x and the y coordinate, the y-intercept. Okay, that is going to be 0, negative 8. All right. So every time you report features on the graph, you have to give both the x and the y coordinate. If you are going on to calculus, this is an extremely important thing to start getting in the habit of because your calculus teacher will take off a load of points if you don't do this. Okay, I will still take off points if you don't do this. So just be careful. Every time you have a feature on a graph, you have to report both the x and the y. Again, the turning points, we don't really care where they are as long as there are only two of them. Okay, there's n minus 1. Whatever the degree is, minus 1. That's the only thing we care about. Is it continuous? For the most part, yes. We write chromie penmanship, but notwithstanding. But yes, that's about all we're going to do. So we have all the intercepts sitting here. We have the y-intercept sitting here. We have our end behavior. We're good with this problem. We're going to call it done. Okay, so I'm going to say very much. Thank you very much for watching the video, and I will see you in the next one. All right.